Some of the patterns too, I think it's worth mentioning here too for solving for our technical debt. I mentioned what we have there. So we should try to come up with some solutions around that, at least at a high level of what we can work with and how we can work, figure those in. So for solving for those technical debt in some of the areas you have, it depends what kind of it is, but there are different solutions for each. So the first is what I would call implement an event sourcing architecture. So this is a decoupling approach to your application stack where you're treating everything that happens within your organization as an event and being able to take that event and do this in an asynchronous way. So that this works great with like mainframe development, for instance, because you can essentially put a adapter or a facade in front of your mainframe, and as an event comes into the system, the mainframe can pick it up and process it in its own time frame. So these mainframes are usually typically 10, 20, 30, 40-year-old systems, not built for those high throughput systems we have today. So by giving them essentially a throttle in front of them that will pull the messages as fast as the mainframe can consume it, we can work with that interface for our new design. This also allows us to essentially build all of our new code on top of that interface. And then as we go in and start to replace and update and refresh some of that mainframe code, we don't have to rebuild the entire system. We're already interfacing with that facade. We can just swap out the interface, plug in the new system, and we're off to the races. We want to also start pushing some of that data to the edge. With the eventual consistency and using the event sourcing, we can now make copies of that data so that it's closer to your end users. So if you think of a web application that needs to read information from a mainframe, for instance, or from some legacy database or what have you, in our typical approach, we have to traverse the entire network. In this approach, we're making a copy of the data so it's eventually consistent at the edge, and we can just read that from the the local system without going through the whole process. Automation is key with all of this, whether it be automating our SDLC process for releasing code, for building code, for security scanning, even for provisioning architecture and new environments. Automate everything from the start, and making that a kind of a pillar of the approach is crucial, and that includes your testing as well. And then finally, another way that is kind of newer, and I have a little bit about this at the end here, but basically using techniques for migrating mainframes. So there are processes and solutions out there that can actually literally take your mainframe, do a code scan of that COBOL or that Fortran or that RPG, whatever it is, and will automatically convert it into a more modern language and deploy it. This gives you a path out of that $62 million licensing fees that you're paying these organizations, and really frees you from that crutch that is supporting your business. Well, at the end of that, leveraging ML and AI to take advantage of that and to really get some predictive analytics.